Hello friends, welcome to another tutorial in network analysis series. Today I'll discuss two gate questions out of network analysis section. The first one being a question on the analysis of a series network, single loop series network, pretty simple. Now if you look at this question asks you to find the value of I of t, which is the current under steady state, and four options are given. Now if you look at this question closely, this is a classical example of superposition theorem being used in a case of a hybrid network. Now once you understand that the current in this network is because of these two sources, and the impact of these two sources must be clear to you. This voltage source with the 5 volt DC will eventually give us a steady state current of 0. So you could say that DC voltage of 5 volt will give me a steady state current of 0, and the reason for that is you know that the capacitor will act as an infinite reactance component towards DC, and the steady state of a capacitor is it blocks DC at all, so you would not have any current because of this DC voltage source, and hence the current will be 0 because of this DC voltage. So I can say I1 because of the first voltage source will be 0. Now we are left with the second voltage source, which of course is an AC source, and over here you simply need to understand that this 10 sine t gives me an omega is equal to 1, because the generic form gives me 10 sine omega t, and omega here is 1. So the generalized form of the voltage is maximum voltage sine of omega t plus minus the phase difference. So there is no phase difference and omega is 1, and because omega is 1, the things becomes a lot easier. The current becomes the voltage upon the impedance, which is 1 plus 2j plus 1 by j, because the reactance here will be omega L, and over here it will be 1 upon j omega C, it will be j omega L, omega being 1, so we get this. So what we are left with is 10 sine t upon 1 plus j, and converting it into polar format, I'll get 10 upon under root 2 of sine of t minus 45. So eventually this thing is 7.07, so the answer is D. So it's a classical example of superposition theorem being done rightly. So you need to get your fundamentals placed correctly in order to solve this tricky and yet simple question. And the next question that I want to discuss today is this infinite ladder network. If you ever encounter this infinite ladder network and you need to find the driving point impedance of this network, you can simply commit to your memory a formula which is the our equivalent of such a network is under root of r1 square plus 2 times r1 r2. So the equivalent resistance will be the r1 square, which is the series resistance appearing in the series arm, and plus 2 r1 r2 under the root. So this is CTM, very important for quick solving of questions in GATE. So if you remember this formula, you'll be able to solve it in no time. So 2 into 2 into 1.5, so it will become under root of 10, and under root of 10 is 3.5 ohm. So this will be the correct answer. So I hope these two quick fire questions will help you brushing up your fundamentals and getting prepared for the GATE examination. I hope this video was of help. If you liked the content, give it a thumbs up, consider subscribing to the channel. I'll see you in the next one. Take care. Bye bye.